All right, we did number 101 in class today, but I thought I'd go ahead and put it on here just in case somebody wanted to see it again. Number 101, we've got the function x squared plus 3xy plus y cubed equals 10. And we want to take the derivative of this. We're going to have to do implicit differentiation on this because it's impossible for us to get y by itself and to take the derivative just of y in terms of x. So we're going to take the derivative straight across and apply the rules as we know them. So let's start on the left-hand side where we've got three terms. We'll take the derivative of each term separately. First, the derivative of x squared is 2x. And we talked about how that's 2x, and that's the derivative of x with respect to x. So we could say 2x dx dx, but the change in x with respect to x is just equal to 1. So it's somewhat pointless to write dx over dx. That's just equal to 1, so we don't bother with that. And that's important, though, because when we go to take the derivative of y with respect to x, we're going to get a dy dx that's not going to go away like the dx dx just did. All right. Move on to 3xy, use the constant multiplier rule and say that's 3 times, and now we want the derivative of x times y. But that's a product, so we're going to have to use the product rule to take that derivative. So I'm going to go first, which is x, times the derivative of y. Well, the derivative of y is 1 dy dx, so that's 1 times dy dx. Now we can use the dy dx notation, or we've generally in class used this what looks like a little simpler notation and just use y prime. They're really the same thing, just a different way to write it. So x times the derivative of y plus, now we reverse it, the second function of y times the derivative of x. Well, the derivative of x is just 1. And again, we could say 1 dx dx, but dx dx is, again, just 1. All right, so we're finished with the middle term. Now let's move on to y cubed. So I'm going to get 3y squared, but again, that's dy dx, or y prime as we kind of prefer to write it. On the right-hand side, the derivative of any constant is just 0, so that's what I get after I've taken the derivative. Now, we'd like to do a little algebra on this to solve this for y prime. That's the derivative we're looking for. So let me start here by distributing that 3x plus 3x y prime plus 3y plus 3y squared y prime is equal to 0. Now we're going to take any term that does not have y prime in it over to the other side of the equation, and I'll leave the y prime terms on the left. So I have 3x y prime, that stays here, and the 3y squared y prime stays here. On the other side, I'm going to move the 2x over, it becomes negative 2x, and we move the 3y over, and it becomes negative 3y. Now we've got y prime in each of these terms on the left, so we'll just factor it out. Y prime times 3x plus 3y squared equals negative 2x minus 3y. And then we'll just divide both sides by this factor multiplying the y prime, and I end up with y prime is equal to negative 2x minus 3y over 3x plus 3y squared.